The planet looks peaceful from space. Blue shadows, soft clouds, a glowing curve of light along its horizon. But the moment a human foot touches its surface, bones begin to crack. Welcome to a world where gravity is not just stronger, it is crushing. Astronauts imagined leaping across alien landscapes like on the moon. But on this planet, you wouldn't jump. You wouldn't run. You wouldn't even stand for long. Your chest would feel like a truck parked on it. Your heartbeat would struggle. Your blood would sink downward, pooling in your legs. Breathing would become a fight, and within minutes, your own body weight could become deadly. This is not science fiction. This is a real type of planet scientists call a super-Earth. Massive, rocky worlds, far larger than Earth, orbiting distant stars across the galaxy. Some may look familiar. Some may even have oceans. But beneath their beauty lies a force so intense it could slowly kill a human simply for existing there. What if humanity tried to colonize one? What if Earth itself somehow became heavier? What if gravity increased just a little more each year? Because gravity doesn't need to double to destroy civilization. An increase of only a few times Earth's pull could rewrite biology, architecture, transportation, even survival itself. On a super-Earth, mountains would be shorter, crushed under their own weight. Rivers would flow differently. The atmosphere would be thicker, heavier, pressing down like an invisible ocean of air. Creatures there, if they exist, would be squat, dense, and built like living tanks just to move. But humans? Humans evolved for this planet, this gravity, this delicate balance. And when that balance changes, life changes with it. Some super-Earths are believed to have gravity 2, 3, even 5 times stronger than Earth's. On the most extreme ones, simply lifting your arms could feel like lifting concrete blocks. Walking would be exhausting. Standing could damage your joints. Lying down might be the only relief. And yet, these worlds may be some of the most common planets in the universe, more common than Earth itself, which raises a terrifying possibility. What if most habitable planets aren't truly habitable for us at all? What if the universe is full of worlds that look perfect, but are physically impossible for humans to survive? For decades, scientists searched for planets like Earth, but what they found instead were giants, heavier, denser, stronger. Worlds where gravity rules everything. And now the biggest question isn't whether super-Earths exist. It's whether life can thrive under such crushing forces, and whether humanity could ever adapt to a universe that might be far heavier than we imagined. Because if gravity is destiny, then most of the cosmos may already be closed to us. And the real danger isn't space itself. It's the invisible force pulling us down. The discovery didn't begin with telescopes powerful enough to see alien landscapes. It began with tiny shadows. Astronomers noticed stars dimming, just slightly, as unseen planets crossed in front of them. These dips in light were small, precise, repeating like a heartbeat. And from those rhythms, scientists could calculate a planet's size, its orbit, and eventually, its mass. That's when the shock came. Some of these planets were only twice the width of Earth, but up to 10 times heavier. Imagine compressing 10 Earths into a body just slightly larger than our own. The result is a world of incredible density, rock packed tighter than anything on Earth, gravity pulling with relentless strength. These were the first super-Earths. Not gas giants like Jupiter, not gentle like Earth, but enormous rocky worlds built like cosmic anvils. One of the earliest discoveries forced scientists to rethink planet formation itself. It orbited so close to its star that its surface likely glowed with molten rock. Yet its mass was staggering. Calculations showed surface gravity more than 3 times Earth's. On some even denser planets, gravity could reach 5 or 6 times stronger. To understand what that means for the human body, researchers ran simulations used for high-gravity training in fighter pilots and astronauts. Even brief exposure to forces above 3 Gs causes tunnel vision, loss of consciousness, and organ strain. But that's in short bursts. On a super-Earth, that pressure would never turn off. Your muscles would constantly fight just to hold posture. Your heart would work overtime to pump blood upward. Your bones would compress slightly under your own weight every second of every day. Over time, joints would erode, spines would curve. Breathing would become laborious as heavy air pressed on lungs. But gravity's influence doesn't stop with biology. It shapes the planet itself. Stronger gravity pulls materials closer together, preventing tall mountain ranges from forming. Earth's Himalayas would collapse under super-Earth gravity, flattening into rolling highlands. Volcanic eruptions would behave differently, lava flowing thicker and slower. Tectonic plates would move under far greater pressure, possibly causing more frequent megaquakes. Even the atmosphere changes. Heavy gravity traps gases more effectively, creating dense, thick skies that could be many times heavier than Earth's. A human stepping outside wouldn't just feel heavier, they'd feel buried beneath air. Yet paradoxically, these planets may be better at holding liquid water. Strong gravity prevents atmospheres from drifting into space, protecting oceans for billions of years, which is why many super-Earths sit right in their stars' habitable zones. Warm enough for water, stable enough for long-term climates, seemingly perfect for life. But perfect for whom? Because while microbes might thrive, complex life like humans would face a nightmare of physics. Every movement would cost energy. Every breath would be harder. Every year of life would strain the body faster than on Earth. The universe, it seems, builds worlds heavy by default, and Earth may be the rare exception. A fragile balance where gravity is just gentle enough for forests, oceans, and walking upright to exist. Which leads to an unsettling thought. We didn't just evolve on a planet with life, we evolved on a planet with the right gravity, and without it, the human story might never have begun. Now imagine the impossible becomes reality. Humanity arrives on a super-Earth. The ships land. The doors open, and instantly, explorers feel it. A force pressing them downward like invisible hands made of iron. Each step sinks deeper into the ground. Knees tremble, spines compress. Breathing sounds louder inside helmets. At twice Earth's gravity, movement already feels like wearing a heavy suit of armor forever. At 3 times, simple walking becomes exhausting labor. At 4 times, standing upright is agony. On the strongest super-Earths, humans would collapse within minutes. But suppose technology keeps colonists alive. Reinforced exoskeletons, artificial gravity compensation, medical enhancements. Even then, survival would be a constant battle against physics itself. Cities would look nothing like those on Earth. No skyscrapers. They would crush under their own weight. Buildings would spread outward, thick and low, like concrete bunkers hugging the ground. Bridges would be short and massive. Vehicles would crawl slowly, requiring enormous power just to move. Airplanes as we know them might never fly. The thick atmosphere and strong gravity would demand absurd amounts of energy to lift anything off the ground. Space travel from the surface would be brutally expensive, rockets fighting a gravitational prison far stronger than Earth's. Now imagine if Earth itself slowly gained gravity. Not overnight, not dramatically, just 1% stronger each year. At first, no one notices. People feel a little heavier, athletes tire faster, elderly joints ache more than usual. After a decade, average body weight feels like carrying a backpack all day. Construction costs rise as materials strain. Planes burn more fuel. After 50 years, bones break more easily. Obesity skyrockets even without diet changes. Wildlife struggles to run. Birds have trouble taking off. Tall trees collapse. After a century, gravity becomes a civilization-level threat. Farming fails as plants grow shorter and weaker. Infrastructure cracks under stress. Energy consumption explodes as machines fight heavier loads. Humans begin adapting. Shorter stature, thicker bones, denser muscles. Evolution accelerates under pressure. But millions would die during the transition. Hospitals overwhelmed with heart failures. Cities rebuilt lower and stronger. Global economies destabilized by rising energy demands. And if gravity reached 3 times Earth's pull, human anatomy as we know it could no longer function. Children wouldn't grow normally. Circulation would struggle to reach the brain. Pregnancy would become life-threatening. Society would fracture between those who could afford gravity compensation technology and those who couldn't. A new class system, not based on wealth alone, but on who could physically survive. Some scientists believe advanced civilizations on super-Earths, if they exist, would look radically different from us. Short, dense, incredibly strong, built like biological pressure vessels. Their technology might focus less on speed and height and more on stability and strength. In their world, falling from standing height could be fatal. Speed would be dangerous. Everything would be slow, deliberate, controlled. Gravity wouldn't just shape life, it would shape culture. A heavy world would create cautious civilizations, patient societies, creatures who measure every movement. And suddenly our fast, fragile, upright human bodies feel like products of a rare cosmic miracle. Which brings us to the most haunting realization of all. If most habitable planets are super-Earths, then most intelligent life in the universe may be nothing like us. And we may be far less suited for the cosmos than we ever dreamed. When scientists first searched for Earth-like worlds, they believed our planet was ordinary. A small, rocky sphere, liquid water, a stable star. The universe, they assumed, would be full of similar places. But as thousands of exoplanets were discovered, a strange pattern emerged. Earth-sized planets were rare. Super-Earths were everywhere. The cosmos didn't favor gentle worlds. It favored heavy ones. Planets 2 to 4 times larger than Earth dominate our galaxy. Many orbit in the so-called habitable zone, the perfect distance for liquid water to exist. By temperature alone, these worlds look ideal for life. But temperature is only part of the story. Gravity is the silent architect of everything that lives. It decides how tall trees can grow, how fast animals can move, how thick bones must be, how hard hearts must work. And Earth's gravity sits in a narrow, almost miraculous sweet spot. Strong enough to hold an atmosphere, weak enough to allow complex life to move freely. On super-Earths, gravity may be too intense for creatures like us to ever exist naturally. Life there, if present, would evolve under crushing pressure from the very beginning. Not upright walkers, not runners, but dense, powerful forms hugging the ground, built for strength rather than speed, which means something profound. The universe may be full of life, but empty of humans. Our bodies are tuned to a rare planetary setting, a delicate balance that might occur only a small fraction of the time. Earth is not just habitable, it is finely calibrated, and that raises the most unsettling possibility of all. When we dream of spreading across the stars, we imagine oceans, forests, and open skies waiting for us. But reality may offer worlds that are physically impossible to inhabit without extreme technology. Not poisoned by atmosphere, not frozen, not burned. Simply too heavy. Gravity could be the ultimate barrier to cosmic expansion. A wall no spaceship can bypass because it isn't in space. It's in the planet itself. Even if we find paradise-looking planets, stepping onto them could feel like stepping under a crushing mountain. And perhaps that's why the universe feels so silent. Civilizations may exist on super-Earths, trapped beneath thick skies, struggling to reach space, imprisoned by gravity far stronger than Earth's. Their rockets may never escape. Their signals may never travel far. Their worlds may remain isolated forever. Meanwhile, Earth, light, balanced, rare, became a launch pad for exploration. Not because we were smarter, but because our planet was gentler. In the end, gravity may decide which civilizations touch the stars, and which remain forever grounded. The universe may not be hostile, it may simply be heavy. And Earth, against all odds, is the exception. A fragile world where life learned to stand, to run, to dream, and finally, to leave its home planet. So when we look up at the night sky and wonder why no one has visited us, the answer might be quietly pulling at our feet. Because most worlds aren't built for beings like us. And in a galaxy of crushing gravity, Earth may be one of the lightest miracles of all.